Welcome to today's episode of Tech Tidbits, where we break down complex tech topics into bite-sized, engaging discussions. Today, we'll be diving into a fascinating aspect of programming that's essential for anyone looking to understand networking through Linux: socket programming. So let's get started. Imagine you're in a bustling city, and you need to send a message to a friend across town. You can't just shout. You need a reliable way to get that message over, right? Well, that's exactly what socket programming does for computer networks. It creates a reliable channel for communication between devices. Now, socket programming is a way of enabling inter-process communication. Think of it as the traffic signals of data transmission, where processes exchange messages. The heart of this communication lies in the concept of sockets. Sockets originated from BSD Unix back in 1983 and were standardized by POSIX, making them crucial for modern networking. Let's break down what sockets are. Each socket acts like a door through which data enters and exits a process. There are two primary types of sockets. One, Unix domain sockets. These are used for communication within the same operating system, offering higher speed because they don't have to deal with network protocols. ENet domain sockets. These allow communication over networks, using TCP/IP protocols to manage data transmission. Speaking of TCP and UDP, let's talk about their differences. TCP is all about reliability, ensuring your data gets delivered correctly, like a fast courier service. In contrast, UDP transmits data without guaranteed delivery, much like sending a postcard that may or may not reach your friend. So think about it. If TCP is your reliable delivery guy, when might you prefer UDP? In scenarios where speed is crucial, like streaming video, right? It's okay if some data packets are lost. The stream still flows. Now, how exactly do we use these sockets in programming? The beauty lies in APIs, essentially the toolbox that helps us build our networking applications. Functions like socket, bind, and listen set up the communication lines, while others such as receive and send handle the actual data transfer. It's like constructing a building. You lay the foundation, erect the walls, and then decorate it to make it functional. How about an example? Imagine you're building a simple HTTP client. You need to resolve a hostname to an IP address, create a socket, connect to a server, send a request, and then wait for a response. Each step is critical, and our well-designed APIs make this much simpler. We also can't forget the importance of security in today's world. Enter OpenSSL, which provides a layer of security for our data transmissions. Think of it as putting your important documents in a safe box before sending them off. I remember my early days grappling with sockets. I was overwhelmed by the complexity of it all. But once I grasped the concept, a socket is just an endpoint for communication, the pieces started falling into place. There's definitely a learning curve, but the satisfaction of getting a client-server model up and running is incredibly rewarding. Conclusion. To wrap up, socket programming is a fundamental skill in the realm of Linux networking. Whether it's creating a simple application or implementing more advanced features like multi-threading or non-blocking sockets, the basics lay a strong foundation. If you're interested in exploring this further, try your hand at building a simple HTTP server or delve into advanced techniques like I/O multiplexing with select or using poll. As we close today's episode, I encourage you to embrace the challenge of learning something new, because every click, connection, or packet sent is a step into a larger world of technology. Thank you for tuning in to Tech Tid B,